So starting with binomial, right? Binomial theorem. Why binomial theorem is used? What is the use of binomial theorem? So basically it is about finding out the values, finding out the terms in expansion of a bracket. In expansion of a bracket, and during that expansion, sometimes we will go with all the terms. Sometimes we go with like that, okay, what is the fifth term, any specific term with term number, or we go with any coefficient of a variable with some power. So these are the things which we solve by using binomial theorem. Okay. So first of all, what I'm going to do over here, for instance, you are having a plus b whole power 0. Okay, a plus b whole power 1, a plus b whole power 2, a plus b whole power 3. Okay, first of all, you have got this one. So when I will expand this thing, this will be a plus b whole power 0 will be equals to 1. Power 1, that will be a plus b. Power 2a square plus 2ab plus b square. Okay, a cube will be a cube plus 3a square b plus 3ab square plus b cube. Okay, these are the things which we will do when we are having expansion. Now the first thing you can see over here, power is 0, number of term is 1. Power is 1, number of terms are 2. Power is 2, number of terms are 3, and power is 3, number of terms are 4. So it means in an expansion, comma, number of terms will be equals to n plus 1. Okay, the number of terms which we have to get after expansion, that will always be equals to n plus 1. That is the first thing I am giving you over here. Okay. Now I have got an expansion over here of a plus b whole cube, which is a cube plus 3a square b plus b cube. Okay. Now inside the bracket, power is 1, whole power is 1. Okay. Outside the bracket, for each term, if you are going to add their powers, like what is the power over here? Power is 3. What is the power over here? A square and b power, then a power 1 b square and then b cube. All of them are sum up to 3. This is 3. 2 over here, 1 over here, add up to 3. 1 over here, 2 over here, add up to 3. And this is also going to be 3. So we can say that in this type of expansion, the total power over here will be equal to sum of these powers. But what is the important thing? First of all, inside the bracket, it should be 1 and 1. Only then you can do it. Okay, so it is not a general rule. It is just a small trick which I am telling you over here. Okay. So now, with the help of this example, now I am going to write a general formula over here. What is that general formula? The general formula of binomial theorem is TR plus 1 NCR A n minus R and b to the power R. Okay, this is my general formula. Now we are going to simplify it, and we are going to, now I'm going to explain you what is the each term expressing over here. Okay, first of all, n is expressing whole power on the bracket which is supposed to be expanded. Okay, in this case it is 3. N will represent whole power of the bracket which is to be expanded. Okay, first thing. Now A will represent first term in the bracket which has to be expanded. B represents second term of the bracket which has to be expanded. Okay. Now, what is the power of A right now? The power of A is written N minus R. And power of B is written R. If I add both of them, power of first term was N minus R, power of second term is R. If I will simplify them, so the result will be N minus R plus R. This will be cancelled. So the result will be equals to N minus R plus R. The result will be equals to N. And what was N? N was the whole power which I have told you over here. So in each term, if you will add the power of the given variable, it will mostly equals to the given whole power of the bracket. Okay, not in every case, but mostly it will happen. Okay. Now after this, uh, I have explained you that n will always represent whole power. A is first term, B is second term. Okay, these things I have explained to you over here. Now let's write this thing over here and compare it with this one. This thing NCR, the combination thing that we will do when we are going to work out with unknown powers. Unknown whole powers is given. So let's write these things. A cube b power 0 or a square b power 1 or a b square or a to the power 0 b cube. Okay, they are written in a pattern. The first term is having descending powers and the second term is having ascending powers. See over here. The first term is having descending powers and the second term is having ascending powers. Now, let's compare it with this one. See, a n minus r b to the power r. So, okay, which term is this one? I haven't written my coefficient right now. I'm not talking about the coefficient. I'm just talking about the variables right now. So, this is my first term. Okay, this is my second term. And this is my third term. And this is my fourth term over here. Okay, this is my fourth term over here. Now, if I will compare it with this one, a n minus r b to the power r. See, what's b over here? B to the power 0. So it means in this term, the value of r is equals to 0 if I compare it with this thing. R equals to 0 because b to the power r is the part of the formula. So b to the power r and b to the power 0, it means r is equals to 0 in this one. Okay, let's talk about this one. I'm not talking about this one right now. I'm just talking about this thing. B to the power 1, b to the power r. It means r is 1 over here. In this one, r will be 2. In this one, r will be 3. Okay. When I'm comparing it with this one, I have written what will be the value of r for this term, for this term, for this term, and for this term. Okay, that I have written over here. Now, let's compare it with something else. First term, r will be 0. Second term r will be 1. Third term r will be 2. Fourth term r will be 3. What does it mean? It means the value of r will be always one number lesser than the term number. If first term, r will be taken as 0. If third term, r will be 2. If I'm talking about fifth term, r will be 4. If I'm talking about seventh term, r will be 6. In this same way, if I'm saying the value of r is 8, what will be the term number? You will say, okay, 8 plus 1, term number will be 9. If I'm saying r equals to 17, which term number? R plus 1, term number will be 18. So see, over here I have written what? For term, any term, it will be always R plus 1, where R is what? R is 1 minus term number minus 1. R will be always term number minus 1. If it's fifth term, R will be 4. If it is 17th term, R will be 16. Always one number lesser than your term number. That thing will represent your value of R over here. Okay? Okay, so we are going to start with question number 1C, in which they are saying expand the following. Okay, expand following. Question was given, and the question is given 2 minus 1 over 2x whole power 6. Okay, this is the thing given to us. Now, what we are going to do, we have to expand this thing, and for expansion, I have to use binomial theorem. For expansion, I have to use binomial theorem. Now, binomial theorem is TR plus 1 equals to NCR A n minus R B to the power R. Okay. Now, in this one, what is n? Your n is 6. N equals to 6. What is your A? A is your first term. In this condition, it is 2. B, what is B? This whole thing. Your B is minus 1 over 2R. That's your B. Okay. And what is R over here? Sorry, not 2R, it's 2x. And what is R over here? R is term number minus 1. So R is not fixed. R is going to be changed with each term over there. Okay. So now they are saying that we have to expand it, and previously I have told you guys that when we are expanding anything over here, the whole power is 6. So it means from here total terms will be 6 plus 1. It means 7 terms I am going to get from this expansion. Okay, these are the starting points. Now, how we are going to have these ones, how we are going to solve it. So first of all, I am going for my first term, 1. My first term is T1. After that, N, what is N? 6. C, now R, what is R? R is term number minus 1. What is the term number? Term number is 1. So R will be 1 minus 1. R will be 0 over here. Okay. After that, A. What is A? A is the first term. 2. N minus R. N is 6. R is 0. And then B. What is B? Minus 1 over 2x whole power 0. Okay, simplifying it, T1 equals to 6C0 will be 1, 2 to the power 6 will be 64, and this thing with power 0 is also equals to 1. So T4 is coming, T1 is equals to 64. That's your first term over here. Right. So now I'm going for T2. That is my second term. So 6 C R. R will be what? One number less than this. So one number less than this will be 1. 6C1 into A. What is A? Your first term. A is your first term. That is 2. N minus R. That is 6 minus 1. B to the power R means minus 1 over 2x power 1. Okay. So T2, 6C1. 6C1, you can use your calculators. So 6C1, the answer will be coming 6 into 2 to the power 6 minus 1 will be 5, that is 32, into power is odd, so minus will remain minus 1 upon 2x. Minus 1 upon 2x. Now, 2 ones are 2 and 2 into 16. Okay? 2 ones are 2 and 2 into 16. I have started by simplification now. So, T2 equals to 6 into 16, the answer will be 96 over x, and minus sign is there, so minus sign will be written over here. Okay, this is my first term and this is my second term. Right? Now going for my third term, T3, 6C R, I have to write R. R is one number lesser than this. 6C2 into 2 to the power 6 minus 2 into B to the power, it is B minus 1 over 2x. Minus 1 over 2x. Okay. Minus 1 over 2x. And minus 1 over 2x, then R. What is R? R is one number lesser than this, so that is square over here. Okay, this I have got. Now simplifying it. So first of all, I have got 6C2. So I will use my calculator, and C2 is going to be 6C2 is going to be 15 into 2 to the power 6 minus 2. 2 to the power 6 minus 2 will become 16. Okay? Square is there. On this bracket, I have got a square. This is written over here. On this bracket, I have got a square. So minus 1 square will be 1 over 2 square will be 4. X will be x square. Okay, so when I am going to simplify them, the answer of this whole thing is coming 60 over x square. 15 into 16 into 4. 4 ones are 4. 4 fours are 16 and 15 into 4 is 60 over square. That is my third term over here. Okay. I have to go till seventh term. Okay. So now for T4, it will be NCR, N is 6. So 6C, R is one number lesser. So 6C3 into A. What is A? 2 is given, N minus R. So 2, 6 minus 3 into 1 over minus 1 over 2x whole power 3. Okay, this is I have got. Now 6C3, I am solving it by using calculator. So 63 is coming 20 into 6 minus 3 will be 2 cube, and 2 cube will be equals to 8 into power is odd, minus side will remain, minus 1 over 8x cube. 8 and 8 will be cancelled, so this will be minus 20 over x cube. Okay, that's my T4. After that, T5. 6C4 into 2, 6 minus 4 into minus 1 over 2x whole power 4. So 6C4, I think the answer will be equals to 15. T5 equals to 64, answer is 15 into 2, and 6 minus 4 will be 2, so 2 square, the answer will be coming 4 into 1 over 16x4. So simplifying it, 4 1s are 4, 4, 4, 16. My final answer will be for this one is 15 over 4x4. Okay? Right? Now, T6, 6C5 into 2, 6 minus 5 into minus 1 over 2x whole power 5. So T6 equals to 6C5 will be 6 into 2 into minus 1 over 32x power 5. Okay? So when I will simplify it, 2 1s are 2, 2 16, 2 3s are 8. So minus 3 over 8x5. Okay, last T7, 6C6 into 2 6 minus 6 into minus 1 over 2x whole power 6. So when I am going to simplify, T7 equals to 6C6 will be 1. 2, 6 minus 6 will be 0, so power 0, 2 power 0 is also 1, and this will become 1 over 64 x power 6. So when I will simplify, my final answer will be 1 over 64 x power 6. These are all the terms written separately. T1, T2, T3, T4, T5, T6 and T7. All the terms are written separately. Now I am writing them together. Okay. Now I am writing them together. So the expansion of this thing will be 64 minus 96 over x plus 60 over x square minus 20 over x cube plus 15 over x 4x4 minus 3 over 8x5 plus 1 over 64 x power 6, and how this is how you are going to do the expansion. Okay. One more thing, always remember beta, when you are taking your combination, upper one was written n and the lower one was written r. So always remember, value of r can't be greater than the value of n. Okay? Maximum it can be equal to n, but it can't be greater than n. Okay? Take care of this thing.